Hello.
Hi, Taylor. How are you?
Good to you?
Good. You can hear me okay?
Yes.
All right. So yesterday we worked on sum and difference, but we really only talked about cosine.
Yes.
What have you gone on to double angle yet, or are you still on sum and difference?
We're pretty much still doing the same thing, some difference.
All right.
One I had a question on, which I was confused about, was cosine.
Okay.
Open parenthesis, negative 7 pi over 12. And then close parenthesis.
And they want to know the answer of this?
Yes.
All right. So first of all, it's useful to know odd-even properties. In other words, is cosine odd or even? Remember from your pre-calc that even means that f of minus x equals minus f of x, and odd means f of minus x equals f of x. Cosine is one of these two. Do you know which one?
Actually, since it's odd right now.
It is odd.
Yeah.
Okay, so the very first thing we know, let's get rid of the negative sign. Okay? So that's the first step. Let's turn it into something that's all positive. Now, 7/12 is one of those numbers that you may not recognize, but it's what 1/4 plus 1/3 is.
1/4 and 1/3.
Yeah, let's add 1/4 plus 1/3. How do we add those two fractions?
Common denominators, which would be 12. Then that would be 3 plus 4. And then
So 7/12 is 1/4 plus 1/3. Okay? And which means that what we're looking at here is the cosine of pi over 3 plus pi over 4. And now we can apply the sum and difference formula. So what is this equal to?
Cosine A.
Well, give me the specific. What's this equal to?
Pi over 3 times pi over 4, right?
Well, times cosine of pi over 4. In other words, that's A and that's B. And then what's the rest of it?
And then when I have to get sine,
is it plus or minus?
It's minus.
Correct. And then the next two terms are both sine. So they're easy enough to remember. What goes there? What goes there?
Pi over 3 in the first one, then pi over 4.
All right. And now let's fill in numbers. What's cosine of pi over 3?
1 over 2.
What's cosine of pi over 4?
Square root of 2 over 2.
What's the sine of pi over 3?
Square root of 3 over 2.
And the sine of pi over 4?
Square root of 2 over 2.
And oddly enough, when you do this enough, you get answers like this. That's a very common answer. And that's what the cosine of 7 pi over 12 is equal to.
Okay.
Okay, see how I got everything?
Yes, because my teacher like did it some weird way.
Well, okay. Well, I think probably the most important step, there's multiple ways to do these. In other
Okay.
words, I could represent 7 pi over 12 in a lot of ways. I could represent it as 12 pi over 12 minus 5 pi over 12. No, I'd have to do it the other way around. Minus 5 pi over 12 plus 12 pi. No, hold on. In other words, you can see that there's multiple ways of doing this. I can represent that number in this way. Minus 7 pi over 12 is 5 pi over 12 minus 12 pi over 12. So that would be A and that would be B. The problem is you don't know what the cosine of A is, or the sine, because it's a 12th. So you kind of have to get A and B into angles that you know the answer to. But even still, I mean, that wasn't a good example, but there are literally an infinite number of ways to create that. I can do it with doing that as the first step and then finding pi over 3 plus pi over 4. But there are an infinite number of ways of doing it.
Okay.
And it doesn't matter what you use for A and B. As long as they add to minus 7 pi over 12, then you fill them in for this and you can go forward.
Okay.
Now, let's talk about one other thing. Why do they start off teaching you cosine? That seems odd in itself, does it not?
Yes.
Well, I'm not totally sure, but every book does it. And let's examine what sine is. I think they do it because sine's a little bit easier to remember. But the reason you start off with that is it teaches you that you have 2 cosines and 2 sines. So as long as I know that the answer has 2 sines and 2 cosines in it, and that with sine it's the same, plus minus, it's not opposite, minus plus, and it's sine cosine, sine cosine. So that automatically allows me to memorize it. If it's sine cosine and sine cosine, there's only one other question. What letters go here and here?
A and B?
Yeah, always remember that the letters, and then this has to be the opposite. In other words, once you realize that this has to be A and B, then the second part of it has to be B and A. It wouldn't make sense if this was A and B also.
Okay.
Okay? But notice we have 2 sines and we have 2 cosines, and the only other difference is that is the same. And with that information, that should be enough to memorize it. Okay, now there's a third one that they kind of want you to memorize also. And this is actually pretty easy to memorize. The numerator is the same thing. But the denominator is 1 opposite minus plus instead of plus minus, and in the product, tan A times tan B. So that's not that hard to memorize. And these are the 3 they want you to know.
Okay.
And between these three, you can calculate a lot of trig functions that you wouldn't be able to without a calculator otherwise. In other words, there's more than one beauty to the sum and difference. They're also used in much higher math to manipulate functions and figure out identities and stuff. But the main purpose they're used for at this level of trig is to find angles that we would not be able to do otherwise without a calculator. In other words, with a calculator, you can find the trig function of any angle. But without a calculator, you're kind of limited to 30 degree, 45 degree, 60 degree, 90 degree, or any multiple of those.
Okay.
Well, with the sum and difference, now you can do angles like 75 degrees, 15 degrees, because 15 comes from 45 minus 30. You see what I'm saying?
Yes.
All right. Do you have any specific problems?
I have one that I had confusion on as well, and that is sine 200 times cosine 25, or just cosine 25, plus cosine 200 and plus sine, or sine 25, not plus.
Now, they want you to be able to go either way on these formulas. In other words, if they give you this one, they want you to be able to come up with that. But if you are looking at that one, they want you to be able to go backwards and notice that that's the same as the sine of A plus or minus B. Okay, well, what are we looking at here? We're looking at this one right here. Just because they switched sine and cosine here, we can switch them back. In other words, the associative property still holds. You see what I'm saying? In other words, this part here I can write as sine 25 times cosine of 200. Let's do that, and it makes it a little bit more logical. In other words, when I see this, I'm looking at this. Okay, so what should that be equal to? The sine of what? If we go from right to left.
So I can't add them together?
Yeah.
Wait,
So that's the same as 200 plus 25.
Okay.
Notice that this is that, or that. In other words, when we see sine of some angle, cosine of another angle, plus or minus, sine of the other angle, cosine of the first angle, we should be thinking plus or minus. And since this is a plus, I know that this identity, the signs stay the same, so it has to be the sine of 200 plus 225. Okay, so this is going to be equal to the sine of 225. What's the sine of 225? Which quadrant?
Oh, that's the third quadrant.
Okay. What's the equivalent first quadrant angle?
Root 2 over 2.
Okay. Plus or minus?
Minus, because it's in the third.
And there's your answer. So that's what your expression was equal to. In other words, this expression, sine of 200 cosine 25 plus sine of 25 cosine of 200 is equal to negative root 2 over 2. Just working backwards instead of forwards. In other words, it would be hard to work forwards because we don't know what the sine of 200 is. nor do we know what the cosine of 25 is. Those are not one of the common angles. Okay? So the only way I can do this problem without a calculator is to recognize that that's the same thing as the sine of 200 plus 25. Now I have a number that is a multiple of 45 degrees, and that's all I need to come up with the answer. Okay, what else? You done tangent yet?
No, not yet.
Okay.
Another problem I have is sine 5 pi over 3. Or parentheses around the 5 pi.
Well,
And then
I think they
plus 3 pi over 4.
like this.
Open up the parentheses on the right of the 5 pi and then close it at the end of the 3 pi.
All right. That makes more sense. Why does that make more sense? Because now we're talking about the sum and difference.
Yes.
So what's the generic? In other words, what is sine of A plus or minus B? Always start with the generic if you're trying to learn something. In other words, the general formula. Because if you repeat that every time, it'll really lock into your brain good.
So I couldn't do common denominators?
That's going to give us 20 pi plus 9 pi, 29 pi over 12. You won't know how to do that either.
Okay.
These are actually angles that we can figure out how to do. In other words, those angles are multiples of 30, 45, or 60, and we can figure out how to come up with these values. And so all we need is the sum or difference to do it. If we add those two values together, we're going to have an angle that we don't know how to figure out.
Okay.
Okay, so what's the general formula? Remember, there's two sines and two cosines in it.
So then it would be sine 5 pi over 3.
Well, let's write the complete general.
Then sine A times cosine A.
Cosine B. That's the only part you can get wrong.
Okay.
In other words, that's the only question mark. Is that an A or is that a B? And it's always different letters. Now, is my sign the same or is it different?
It's different.
It's the same for sine.
How so?
It's different for cosine. In other words, cosine plus minus becomes minus plus. But for sine, these signs stay the same. And what does the rest of it have to be if I know there's two sines and two cosines in this thing?
Got two sines then. Would I have sine times sine?
That would be three sines.
Okay. So would it be sine A and then cosine B again?
That's the same as the first. We need it to be different.
Well, I have no idea then.
Well, then it's sine B cosine A.
You just flip it.
Yeah. In other words, a lot of memorization, you don't have to memorize the whole thing. You just have to memorize part of it. In other words, I never memorized that whole thing. What I memorize is the fact that there's two sines and two cosines, that this sign is the same as this, and that these letters are different. That's all I have to memorize. And then I can figure out the whole thing. And
Okay.
that frequently is the secret to a lot of memory problems in Trig. Because Trig is, more than any other math that you've encountered, memory. There's just lots and lots to memorize. Well, if you can figure out a rhyme or a reason for memorizing, it's helpful. Okay, so now that we have the general, what is the specific?
Then it would be 5 pi over 3. Cosine 3 pi over 4. Minus.
Plus. Sine stays the same. In other words,
Okay.
when I write plus minus there and plus minus there, it means that if it's a plus, it stays a plus. If it's a minus, it stays a minus.
And then you only
With the cosine, it's opposite. In other words, if this was a cosine and this was a plus, then I would have a minus there.
Okay.
Okay, that's the key difference. Here, let me just write it. The general formula, that's what this means. When I write plus minus there, and then I write minus plus, that means that if the original was plus, then it becomes minus. If the original is minus, it becomes plus. Notice there's 2 sines and 2 cosines. In other words, the only part you have to memorize here is that part. Because the rest of it can be nothing else, as long as you know there's 2 sines and 2 cosines in it, right?
Yes.
Okay. Well, that's kind of why I believe they start out with teaching you the cosine. In other words, every other trig, they start out with sine and then teach a cosine. But with this sum and difference formula, they start out, every text I've ever seen starts out with teaching you the cosine and then the sine. And I believe the reason is that when you learn the cosine, you realize there's 2 cosines and 2 sines. And that's all you need to memorize the second one. So what's the rest of this?
Then it would be sine 5 pi, or 3 pi over 4. Then cosine 5 pi over 3.
All right, now let's substitute. What's sine of 5 pi over 3? Which quadrant is that in?
4.
Okay.
And that would be negative root 3 over 2.
What's cosine of 3 pi over 4?
That would be second quadrant and negative root 2 over 2.
You're good with those. That's good. That you can recall those so quickly. What's sine of 3 pi over 4?
3 pi over 4. Yeah, that would be root 2 over 2. They're negative, right?
Positive. Sine is positive in the second quadrant.
Okay.
Okay.
Yeah, A, B, C.
And cosine of 5 pi over 3?
That will be 1 over 2.
Okay. And that's the way I recommend doing all of these, step by step. Do not try to take shortcuts. It's really easy to make mistakes if you take shortcuts. So this becomes what? What's the product of those two?
Negative root 3 minus root 2.
We're multiplying. And that's one reason I ask, is because it's really, really easy to make the mistake you just made. Because we see this big negative sign here, it's really easy to subtract these two. But that's why I put parentheses around them, so that we couldn't make that mistake. So multiply everything, what do you get?
So square root times the square root makes it. So then it would be 6 over 2.
Correct. 6 over 4. Remember, we have to multiply denominators also.
Okay.
And negative times negative is positive, so this that I have circled is root 6 over 4 plus what?
Root 2 over 4.
Notice how similar all of our answers tend to look. There's frequently a root 6, there's frequently a root 2, and there's very frequently a 4 in the denominator. Now, if you wanted, you could do root 6 plus root 2 over 4. Same answer.
Okay, just
But you would not want to convert this to decimal, notice. In other words, usually by trigonometry, they want you to give your answers in radical format. They want precise answers. This is the only precise answer, or this, but if the moment I convert it to decimal, I've made it less precise. In other words, I'm giving you an approximation. If I take two irrational numbers and convert them to decimals.
Yeah, that would be a lot to write down.
Well, it just wouldn't be the way to go. You never see that as an answer. I mean, if you're using this to construct a road or something and you have to have a numerical answer, then you convert it eventually to a decimal. But from a pure math sense, you're always going to give these answers in radical format because this is the most precise answer. I mean, I can convert that to, I can round that off to a hundredths place or a millionth place if I want more precision. But if I want complete precision, I'm using this. Square root of 3 plus square root of 2 over 4, same thing as this up here. But,
okay.
all right. You have any other last questions, Taylor, before we wrap it up?
Yes, I have one more.
I'm sorry?
Yes, I have one more.
Okay, what is it?
Cosine, open parentheses, 5 pi over 6 plus 4 pi over 3.
Plus 4 pi over 3?
Yes.
All right. Now, again, we could add those two fractions, but we get 13 pi over 6. Yeah, we could even do that one. Or did I do that right? Yeah, that's 8 pi over 6. So we actually know how to do that. That's the same as the cosine of pi over 6, which is square root of 3 over 2. So that's our answer. But they want you to do this the hard way, in this case. In the last problem, it was the only way. But in this problem, we're going to use the general formula. What's the general formula of cosine A plus or minus B?
Would it be cosine B?
Cosine A. Remember, there's two cosines and two sines.
Okay, then it would be sine B.
No, the cosine always starts out cosine, cosine.
Wait, so then how do you determine which thing? Because I remember the last formula was a different way.
Well, that was because it was sine.
Okay.
In other words, you have to distinguish between these two. They
So I gotta
both have two cosines and two sines, but there's a significant difference.
Okay, then sine A and sine B.
Right. Whereas this one has the sine A, cosine B. The sines are the same. And then sine B, sine A, or cosine A. In other words, the only other combination. Okay?
Okay.
So if we're working off of the first one, now let's use this. We know the answers for each of these. And that's the key. If you know what cosine and sine are for those, then you want to use sum and difference because you're going to be able to figure out the answer. So what's it going to be?
So then it would be cosine 5 pi over 6 and cosine 4 pi over 3. Then, since it's the opposite in cosine, it's a negative, or minus.
Correct?
Then it would be sine 5 pi over 6 and sine 4 pi over 3.
Okay. Let's plug in numbers. What's cosine of 5 pi over 6?
1 over 2. Or no, root 3 over 2. Actually, no, was that right? 1 over 2?
Positive or negative?
Positive.
It's in the second quadrant.
Or negative root 3 over 2.
There you go. That's the same as 30 degrees.
Okay.
Cosine of 30 is root 3 over 2. It's negative because it's second quadrant. I'm going to put parentheses around it so we'll make sure we're multiplying. What's cosine of 4 pi over 3?
Negative 1 over 2.
Now this negative sign is a negative sign. Just to make sure I don't make any mistakes, I'm going to put my parentheses. What's sine of 5 pi over 6?
Negative root 3 over 2. No. 1 over 2.
Positive.
Yes.
Okay, and sine of 4 pi over 3?
Negative root 3 over 2.
And as long as you write it like that, you're not likely to make mistakes. And then reduce it accordingly. What's the product of those two?
Root 3 over 4.
And what's the product of these two?
Root 3 over 4.
Positive or negative?
Would it be positive because there's a negative on the left?
Yeah, but do it in 2 steps. In other words, multiply that by that, which gives you negative root 3 over 4. Now, because we have a negative and a negative, it becomes a positive. So what's the answer?
So then it's root 3 plus root 3 over 4.
Combine them. It's root 3 over 4 plus root 3 over 4.
Then that would be 2 root 3 over 4.
Simplify.
2 root 3 over 4.
Simplify.
Oh, okay. Then that would be root 3 over 2.
There you go. In other words, if you gave that answer, I'm sure you'd lose points. Unless it's multiple choice. You always have to simplify it.
Simplified form,
Yeah.
Okay, well, thank you.
You're welcome, Taylor. Talk to you next time.
Okay, sounds good. Bye.